Hey guys, welcome back to part 4 of coding asteroids in TypeScript. Today we're going to take a look at thrust and a way to propel our ship based on key inputs. We'll also make some design updates to our ship, and based on the thrust value we'll also add a little flame to visualize if a player is being propelled forward. Alright, so let's get started. I'm going to go back to my code editor. First thing I'm going to do is I'm going to define some thrust value. Okay, so we will say player thrust. Let's give it some value. Let's say 5. It's just some arbitrary number. Once we start actually pushing our velocity with this thrust and calculating the positions, we will retweak it. Okay, so I've defined some player thrust here. So what is thrust, right? So thrust is just a force, and a force you need to apply it in some direction, right? So in our case we want to apply the force towards the direction of the ship, right? So we need to calculate the direction of our ship into a vector form. So when we apply force, we can get the vector of that force and add it to our velocity, right? So that way each time a thrust is applied, you can add it to the velocity. It has to be in the same direction, because otherwise you're not pushing your ship in the same direction as the way it's pointing towards. Okay, so first we need to calculate the direction of our player. So how are we gonna do that? So what we can do, so since we have the angle, we can use some basic trigonometry. Okay, so where do we do this? So let's go to the update function. Alright, so we will get rid of this logic for now. So our player should stop moving. Okay, and we'll define another property on the player called thrust. So I will say it's 0 for now, and when thrust is being applied we'll set it to the player thrust value. Okay, so now how do we compute thrust, right? So how do we compute velocity from our thrust? So we're gonna use the Newton's second law. We have a given mass, so we'll define some mass for our ship. So we will say mass equals, let's say 1. We can make it a constant in a bit, and we can fix our force value. So we can say our force or thrust is player thrust, and we can calculate the acceleration from that. So we can do acceleration is equal to force upon mass, right? And if you have acceleration, you can integrate that to get the velocity, right? Because acceleration is just a derivative of the velocity. So if you integrate acceleration over time, you get velocity back, right? So we need some sort of time in here. So we can use delta time, and then just multiply by our acceleration, right? So we will get something similar to this. Okay, so all right, so let's calculate the direction of our player first. So can I add a function here? Okay, we can create a function here on the player object. This will give us a vector. Right, so first we'll convert the angle to radians. This dot angle to math.pi divided by 180. Same thing as last time when we did the rotation. Yeah, now so let me just quickly show you how to get the x and y components from this. So I have this diagram here. So yeah, let's say your ship is oriented in this way, right, with some angle. Then you can just do cos theta on that angle to get the x component, and sine theta on the angle to get the y component. And we don't need to multiply with anything because we just want the direction, right? So it should already be normalized, because cos and sine, they're going to give us value between 1 and -1. Okay, so let's calculate the x component. So that will be math.cos angle in radians, and then the y component, that will be math.sine angle in radians, and return a new vector with x and y. Okay, now let's first try to draw this direction just to see if it is working. So we can just do a little bit of debug drawing. Okay, probably we can go to draw player, and then yeah, we can do it here. So we will do context dot, let's do a very simple line. You can say stroke style equals red, and then we can move our pen to reset it to 0, because we moved it around earlier here to draw the vertices of the player ship. And we'll also do begin path before this, so it doesn't affect any of the previous path operations. We'll do close path after that, and in between we'll do line 2, and in here we need to calculate the direction of the player orientation. So we will do const dir equals this dot, no, not this dot, is player dot dir. Yeah, so this is normalized already, so we need to scale it to get some length on the line. So let's go to our vector class and add a scale function. We'll say scale, maybe some factor, and we'll just return a new vector with both components scaled. Okay, we go back and we scale this value by some arbitrary number, let's say 20. Okay, so it's not direction anymore, so we can say maybe line target, and we'll say line target dot x, line target dot y. Okay, stroke is already here, so let's see what happens. Okay, I only see a red line. I think I need to reuse the stroke that was there before. Okay, perfect. Yeah, so it should rotate as well to see if, okay, perfect, it works. Yeah, so let's do the thrust computation now. We'll go back to our update, right, uncomment these. So now we have the force magnitude. Need to calculate the acceleration. Okay, so we will say const xl equals so we need a force vector, right? So we can, before we do this, we can say const thrust. So what's the, so thrust is supposed to be a vector, right? Because it's a force. So I'll just say thrust is a vector. It's a new vec2. We can just use the direction. So this dot dir, or this dot player dot dir, and we can scale it by player thrust, right? So that's our magnitude. Well, we can't use the constant because we gotta know if it's 0 or 1. So for now, let's say this player thrust is set to okay, we'll just change it to force. So this will be a vector instead, and then we will say xl is equal to, well, we gotta do force dot scale. We gotta divide, so we can do 1 over mass, right? So now we got the acceleration vector. Now we will add that to our velocity. So we will say this dot, well, we don't have an add function yet, so we can just do it component wise for now. This dot, well, it's not this dot, it's player dot well dot x plus equals xl dot x, and then player dot well dot y plus equals xl dot y, right? Okay, let's also take the thrust from user input. So you can just say if input dot is key down some key that we have not defined yet, we'll just say player dot thrust equals player thrust, and we'll set to player dot thrust equals 0 at the beginning of every update. And we don't need to use this value here, we can just say player dot thrust. Okay, now let's go here and define a new key for thrusting. Space I want to use for shooting, so maybe we can use left shift. I'm not sure what's the key code for that, so let's quickly do let's do it here, console.log key. Okay, it's shift left. So we say shift left equals shift left. Okay, go back, we'll say key dot shift left, then we have player dot thrust equals some value. Okay, we calculate the force, we calculate the acceleration. Yeah, we can try that. I mean, we still need these, right? Because we gotta update the position after we calculate the velocity. Okay, we can clamp the position still. For now, later on, we will see the real behavior is. Okay, I'm gonna try to rotate it, and I'm gonna press left shift now. Okay, that was way too fast. All right, let's clamp on the Y as well, so the player doesn't go out of bounds on the Y side. Okay, let's try that again. Left shift. Okay, it's way too fast. Okay, so first thing we gotta do is we gotta reduce the thrust value to, let's say, 1. Try again. Okay, that's still way too fast. Let's say 0.1. Okay, that's still pretty fast, so let's say 0.1. Okay, since we don't have any drag or deceleration, it just continues. So let's do that first. Then we'll tweak the thrust value. So we can do two things. We can cap the max velocity. We can say cap max velocity, or speed rather, because speed is the magnitude of velocity. And then what we can also do is we can apply some drag to the velocity. Yeah, we can do that here as well. Apply drag. Right, so given no input, it should slow down and come to a stop. Okay, so how do we cap the max speed? So we need to calculate the magnitude of our velocity. So we need to have a magnitude function on our vector class. So let's do that first. So we'll say magnitude, and I will return a number, and it will just be math.square-root of this dot x into this dot x plus this dot y into this dot y. Right, so it's x squared plus y squared and the square root of that. Okay, yeah, that looks okay. Now we go back here, so we can say const speed is equal to player dot vel dot magnitude, and let's define a new function, new constant, to say player max speed equals I don't know, let's say 2 for now. And then we go back, and then we say if speed is greater than player max speed, then we can clamp it down. Then we can say player dot velocity equals player dot velocity dot scale. We basically gotta divide it by a factor of basically the ratio of max speed to the current speed, right? So if speed is greater than max speed, right, then we can do max speed. For example, we can do max speed divided by speed, so you will get something lower than 1, and we can use that to scale the velocity. So we can do player max speed divided by speed, and we gotta make sure speed is not equal to 0 in this case. It can't be 0 because player max speed is some number, and we're checking greater than here. Okay, this looks fine. And now let's also implement drag. So we'll do player.vel is equal to player.vel.scale. Okay, let's define drag value here. Const drag player drag. We can say 0.05 for now. Well, let's do 0.1, and I'll also say 0.1 on this, and I'll do 0.5 here maybe. Okay, we will come back to these numbers once we see what they look like, and then we'll do 1 minus player drag. Okay, so this is drag, and then we're capping the max velocity here, max speed. Okay, let's see how this looks. Rotate. Okay, yeah, the drag is way too much. Okay, I see if you go negative, your values are not clamped back to the screen, because the modulo doesn't remove the sign of the value. It only clamps it down. So we gotta do you can do math.apps on player.parse.x modulo width. We can do that. Or also we could just do if player.parse.x is less than 0, then player.parse.x plus equals width. Same thing for the y, and it'll be height. Yeah, this also works. So now you should not be able to go outside. Okay, yeah, the drag is way too much, so let's decrease the drag. Set it to 0.1 and 0.01. Okay, now it's way too low. To 0.2. I want to try the max speed, lowering it down to see if it actually works. Okay, let's lower it down even further. Let's say 0.2. Okay, yeah, it does work. See, now I can't move much faster. Stuck to the same speed, same top speed at least. Okay, but we can increase it because it looks pretty slow. I mean, it looks okay, but I think it can be tweaked tweaked further. Let's try 0.05 and a drag of 0.15. Okay, that looks okay. Yeah, the top speed is a little high, so maybe I'll do 0.4. Yeah, that looks okay. Okay, I think we can leave it at that for now. Okay, what else? Yeah, one thing we could do in this episode is we can just update the design of the ship, because right now it's just a triangle. But in the original game, it has these wings and then a small inset on this edge. Right? We could also do show the flame when we are thrusting. So in the original game, whenever you're holding the thrust, the flame pulses, so it just shows at some interval. It doesn't stay on fixed while you're holding the button, but it just pulses. So we can do that right now as well. So let's see. Well, to fix the triangle and add those wings, we can just have 2 more vertices in here, and since we're just drawing line by line, we wouldn't need to do anything else. So let's add that. So this is the tip, and then this is the left corner, and this is the right corner, right? So we'll go in between here. I would say new vec2 minus height, and I want to offset a little bit, so I'll do maybe width by 3. Let's try that, and then we can do minus width by 2. Does that look okay? So width by 3 should be pretty small value. Yeah, that looks okay. Then we'll do the same thing for the other point. Just be on the other side. So x will be the same, y can be positive. Okay, let's take a look at that. Okay, perfect. If I zoom in, you can see I have some of these sharp corners. Okay, now we gotta add the flame. So first I'll draw the flame geometry somewhere. We can get rid of this line because we don't need that anymore. We know that our direction logic works. Okay, should be fine now. All right. And then we need to check if you're thrusting, right? All right, so we'll do that here. We gotta do context.move to 0, and we gotta define the flame geometry. So we will say flame vertices equals, we need another triangle, so we'll do new vec2. Now it will be height. We'll do the same thing we did for the tips, I mean the sharp corners that we just added right now. We'll offset the height by some width, and then do minus width by 3 maybe. That's the left side. Right side would be with the plus value, and in between it will be 0. Okay, yeah, let's try to draw this. So we will do, so you know what we can do? We can actually copy this part out to another function. We will say draw shape, and we will say position, and then you'll take some geometry or vertices, array of vec2. I'll put that here. We'll change this to position .x, position .y, tip tail, do context.restore here. Okay, so this is the same as before. Now let's call this back in here. Draw shape, player.position, and vertices. Okay, so let's see if it works as this first. Yeah, okay, it works. And then we will do draw shape, player.position, flame, vertices. Okay, it drew something, but it's just the vertices are not correct. Let me take a look. Wait, maybe I gotta do this first. No, because draw shape has everything localized now. Oh wait, I gotta offset the x-axis to move away from the ship, right? Okay, yeah, there we go. But it does not rotate, so yeah, we gotta add the rotation on it too. We'll do the same thing as above. We'll do v.rotate, player.angle. Okay, rotates now. And then what we want to do is we want to only add this flame tip if you're actually thrusting, right? And you want to pulsate with that. Okay, so let's do that now. Get rid of this context restore, and I'm gonna actually move this function to another class, another file. I'll say it draw.ts, paste it here, call export. Okay, and I need context though. Okay, so I'll do one more thing. I'll create another file called view.ts, and I'll bring our canvas in there. And I'm gonna export all of these. So I'll say export context, height, width, and I'll get rid of the keyboard. Add the keyboard back in here, and I'll also import context and height and width. Okay, and now yeah, if I go to draw shape, actually gotta add the import. Go here, gotta add the import here as well for the context. Import the vector class as well. Okay, that looks okay. Go back to main.ts. Yeah, we can also take the clear screen function, move that to draw, export it, import the width and height from the view, and then fix the bug, fix the import. Okay, now this should be the same as before. Okay, perfect. And now we need to draw the flame only when we are thrusting. Okay, so the very basic we can do is we can say if player dot thrust, only then draw the flame. Okay, so now only if I press shift it should draw. That already looks pretty good. Then if I hold it, it's always stays on. It doesn't look like it's burning. So what I'm gonna do is I'm gonna add some kind of interval. Okay, what we can do is we can say last pulse time, and I'll say performance.now. I can say 0 actually, and then I'll define some interval, player thrust, yeah, I'll say player flame pulse interval, maybe every 100 milliseconds or 200. Let's try 200 first. And then in our update, okay, maybe we can just do that in the, we can just do that here. If now, I need now, so I can pass now from, we have now here, right? Okay, we can do pass in now to the update. This is the current timestamp. So if I say now minus player dot last pulse time greater than the pulse interval, and now on, okay, we need another boolean, so I'll say pulse is false, and then I'll say player dot pulse equal to player dot pulse. You gotta negate it, right? So the timer is running every interval, like this loop runs on every whatever this interval is, just 200 milliseconds, and every 200 milliseconds we flip the player pulse, right? And on top of that we also want to make sure, yeah, this is fine. In the draw we can check if it's so there's two checks, right? One is that there's actually some thrust, and then there's another check that we want to make sure that the interval is passed, right? The time interval has passed. So either we can do both of them here, or we can do the other one in the draw. We can do both here, why not? So we can say player dot thrust is greater than 0 and time has passed. We flip the pulse. Now you gotta always switch the pulse, and then check it in here, because you don't want the timing to be messed up by thrusting or not thrusting, right? I want it to be like a fixed time interval. So we can say here if player dot pulse, then draw it. So let's try that. Okay, it's not drawing at all. Let's see what we did wrong. Okay, we need to update our last pulse time. So this will be player dot last pulse time is equal to now. Okay, there we go, like a blinker. We can make it a little bit faster. Go here, make it 100. Yeah, looks pretty good. Okay, I think this video has been pretty long already, so I'm gonna call it here. So thanks guys for watching. See you next time.